So doesn't that mean my original function is always decreasing? Does anybody have any questions? Yes. I set for the part right here, the f prime undefined part, on the other side, I set the numerator equal to 0. Yes. Yes. I did this right here, went with this. Because the only time a fraction, well, I actually am setting the entire thing to 0. But the only time a fraction can be 0 is if the numerator is 0. So the function is always decreasing, correct? All right. What would be our next step? I mean, we could determine where it's going down, where it's going up, right? Let's do that real quick. Where is the function decreasing? Someone tell me where it's decreasing. Everywhere? Be careful though. Yeah, because remember our original function wasn't defined at -3 and 3? So our function isn't, I mean, it's everywhere the function exists, except for the asymptotes. So that's where the function's going down. Where is the function going up? What's that? It's not ever going up. So how do I represent that? Null set. Good. I was hoping someone would get that. Null set. Empty set. Yep. Does anybody play what's that online poker on the phone? What's that called? Shit. On Android. God dang it. Well, I don't even know what it's called. Anyway, my name on that poker is null set. That's my poker name. All right. Do we have any local max, local min? Do you ever see a change from decrease to increase? Okay. Now look, I know it's been a long day. I know y'all are ready for the end of the summer to come, but let me just put something here because I need you to pay attention to this. Let's just say in blue here that this went up. Okay, let's just say for the sake of argument here and just demonstration. Would we have a local minimum and a local maximum? No, we wouldn't. Exactly. Why not? That's right. Because this is not, remember, the first derivative test said, right, we have to go from down to up, but the function has to be defined there. Right? Our function is asymptotic there, so you can't have it go to a lowest point and then a highest, I mean, like go down and go back up. Because that's right, you're never going to have a local max or min at a place where your function's undefined. That's why it's so critical for us to pay attention and just be like, I don't want you to just be like, oh, I see down and up, oh, automatic, it is the minimum. You know, I mean, you got to think through the entire problem and like, understand what's going on. Well, it's going to look like this. It's going to go like this, and then like this. And we're going to have an asymptote like that. So to the left, it's, oh, well, you know what? I would have to draw it like this. This is the way, if I'm drawing it the blue, okay, the hypothetical situation, the left side of that asymptote, we're going down. The right side, we're coming up. That is not a local minimum. But the only way we'd know that is to remember that -3 is where you have an asymptote. -3, the function's not defined. Pardon me? Well, there's only one vertical asymptote, and from one side it goes down, and the other side it goes down towards it also. They both They both explode negatively, I guess you could say. They get very large negative as they approach that. But that was just... Yes, there would be another drawing. Yeah, if you wanted me to draw both of these, I would have something like this. This would be doing this, this would be doing this. Over here it would be doing this, and then over here it would be doing this. That would be, you know, decreasing, increasing, decreasing. All right, what do I need? We're done with that? No local min. No local max. Yep, now step 6, right? Oh, that is step 6. Step 7. Determine all the intervals where we're concave up and concave down. What do you need for this then? You need the second derivative. So let me put the derivative back up here. It was negative x squared minus 9 over x squared plus 9 squared. The second derivative using the... Oh, thank you. That would have been hell later. The second derivative using quotient rule is negative 2x times x squared minus 9 squared minus the derivative of the bottom. Who wants to volunteer the derivative of the bottom? 2 x squared minus 9 times 2x times negative x squared minus 9 all over x squared minus 9 squared squared, which is 4th. Whew. Now this is where I had come into the class to see where y'all were on this, and a lot of people had gotten hung up on the second derivative because they tried expanding all that out. Whenever you do a quotient rule like this, and you have this and you're trying to like break it up and factor, always try and look for common factors here. Like I have an x squared minus 9 here, x squared minus 9 here. What else do I have common in both of these? I have a 2 and an x and a negative. So I'm going to pull out of the numerator, I'm going to pull a negative 2x times x squared minus 9 out of both terms. Now remember, the terms are separated right in here because there's your subtraction. So this is a first term over here, second term's over here. So f double prime of x equals negative 2x times x squared minus 9. That came out, right? That's what I'm pulling out. And now I'm going to use a big bracket. What would be left in the first term if I pulled out a negative 2x times x squared minus 9? Just x squared minus 9. Because I pulled one of them out, right? There were two of them right here. And I pulled one out, which leaves one still there. The minus 2x is gone, but there's still an x squared minus 9 there. That okay? What's left if I pull a negative 2x times x squared minus 9 out of the second one? 2. I'm pulling a negative, right? So plus 2 is still there, and then what else is still there? The negative x squared minus 9. Remember that 2x came out. It was common in both, right? It's kind of like if you took this big clump right here and you distribute it to this and then distribute it to this. you would get back what you had above. All of this over what? X squared minus 9 to the 4th. Help me clean up the inside here. Inside that big bracket. What does that big bracket become when you clean it up? Negative x squared minus 27. Good. All over x squared minus 9 to the 4th. Does anybody have a question? Anybody see anything else we can do? Yes, you can. You can cancel this one with one of those to make it a cubed. And so we sit here with negative 2x. I'll get rid of the brackets. Minus x squared minus 27 over the x squared minus 9 cubed now. That is the second derivative. And we'd like to know where this is undefined and where it's 0, right? I'm going to move to another page. F double prime x equals negative 2x times negative x minus 27. No, x squared, right? Negative x squared minus 27? Or negative 2x squared? Just negative x squared? Okay. X squared minus 9 cubed. Okay, where's this thing 0? Only the numerator, right? So negative 2x, negative x squared minus 27 equals 0. I can divide both sides by 2, negative 2. I get two things. X equals 0 is one equation. Negative x squared minus 27 equals 0. So x equals 0 is one answer, right? What about the other equation? Move the x squared over. X squared equals negative 27. No solution. Where's the second derivative undefined or does not exist? Do you have any issues with the second derivative? Same thing as before, positive and negative 3. So we still have an issue there that causes that thing to go crazy. Are we ready for a number line? What goes on this number line? 0, 3, negative 3. You can see why you're probably only going to have like one of these on your test. On your final. This is what we would consider to be like a capstone problem in this class. If you can do this problem, you know, you're taking first, second derivatives, you're using algebra. I mean, there's a lot of stuff in this problem. So it's the litmus test. Y'all know what I mean by that? I'm going to pick -4, -1, 1, and 4. And where am I plugging those in? Second derivative, right? Second derivative. Let's plug in -4. I'm going to do it up here so we can see it. Oops. What is f double prime of -4? We get, see, -4 times 2, it's going to be 8. What can you tell me about the negative x squared minus 27? What will that always be? A negative number. So I'm just going to put negative in there because I really don't care. And then what about the bottom? When we plug in -4, you get -4 squared is 16. Take away 9. Positive, and then cube, positive. So we get a positive on bottom. So that's negative, right? What does that tell us about our function? It's, oh, be careful. Concave down. What about -1? What's f double prime of -1? Well, let's see. I don't know. It'll be negative, so 2 on top, -1 on the bottom. No, the bottom's negative this time. So you get a negative over negative. So positive. So it's concave up. Plug in 1, you get negative on top, and you get negative on the bottom. Ooh, concave up again. Wait, no, hold on. 1 on the top. I'm going too fast. 1 on top is negative. 1 on the bottom is